All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we're still doing our human emotions detection module. Let's have a look at what we went over today. Now, yesterday, if you recall, we went over the process of modeling our data. Now, today, we went over the process of training it. So let's do some light reading, and then I'm going to show you a few examples. So now we're going to get to our training. We will start by designing our loss function. This is how we will start the function. Unlike before, we had the binary. This time, we'll be using the categorical. One of the parameters we'll have it is the from logits, which is set to false by default. We can visit the TensorFlow website to read the documentation for all the parameters descriptions. When we have from logits equals false, it simply means that we're supposing that what is going to be into this or what is going into this loss function is going to be a logix tensor, which is going to be the case here because we're using the softmax activation. In the case that we didn't have the softmax activation, then we would have needed to set the from logics to true, such that what gets into the categorical cross entropy is a logix tensor. Now let's go ahead and test this example here that we will get from the TensorFlow website. This is the example we're going to use here with our loss function. And let me show you exactly how do we put that together. So you can see this is our loss function here, categorical cross entropy, and then we have from logis equals false because we are using a softmax activation. Now we do have a y true equals 0, 1, 0. Then we have a 0, 0, 1. And then we have a y predicted equals 0. We have a bunch of y predicted that we're going to run through and show you all the different examples that we got from running them. These are all the examples here. As you can see, we ran them all one by one. So for this first one we ran, we got the result of a 1.176932. For the second one here, this y predicted, we got back a 0.10. For this third one here, the 0010 and the 0, we got back a 1.192. And for the last one here, we got back a 16. Now the 16 is so out of whack because as you can notice here, we have a 010 for our actual, and then we have a 001. So the ones are in two different locations, so meaning that the prediction and the true are totally separate. That's why the number is so large. So the smaller the number, the closer to accurate that the prediction and the true is going to be. So all the other ones came back pretty close. As you can see, we can go back to the first one. You have 010, and for the predictor, we have 0.05. 0.95 and 0, pretty close still because you see we have the 1 here and a 9.5 here. Got back a result of the 1.17. Then for this one here, it was the same thing. The only thing we changed was the second bracket here. The second bracket, we have a 0.1, 0.5 is still kind of close to 0. 0.85 is still kind of close to 1. So as you can see for that second one, we got pretty close at a 0.1. And for the third one, with the 0.5 and 0.95 is still close to 1. And then the 0.85 or the 0.1 is 1. So for that one, we got basically 0. This one came back almost the closest with 0. And then for this one here, we have the 0.0. And then we have the 0, then we have the 1, and we have a 0. So you can see the ones are in two different locations. The ones right here is in this bracket, and the ones right here is in this bracket. That's why we got back a 16. This number is so large because the actual location and the predicted location on two totally separate locations. So that's what we did this morning. Just played around with some data, took some notes, and of course we are going to move forward. And I will keep you posted every step of the way. But for now, it's the Python Papi. You guys stay good. Oh, before I let you go, hold on. Let me show you something else. Actually, yesterday I couldn't figure out exactly where we specified our 16 filters. My fault. I did find it. I was looking in the wrong location. I was checking in here in the dense layers for it, but I should not have been. I should have been checking the COV-Ds. Obviously, it makes sense. So you can see here we have our number of filters, which is set to 6 for our first COV-D, and for our second COV-D, we have a number of filters which is going to be set to 6. But then you see the text afterwards times 2 plus 4. So we have 6 times 2 is 12 plus 4, 16. That's where we get our 16 filters from. So I did go over the code yesterday after we ended the video just to make sure I could find it and see what was going on. And I realized I was looking in the wrong location. So we do have our 16 filters here in our second COV-D. It's just that we don't have it specified as a number. We're just using the generic number of filters, which is set to 6 for both of them. And then for the second one, we're just going to times that by 2 and then plus 4. That's how we got the 16. Yep. That's that. So everything is moving forward. All the data is accounted for and everything is still on track. Like I said, I will keep you posted every step of the way. For now, it's the Python Papi. You guys stay Gucci.